Hello, welcome to questions 85 through 90 from Chapter 5. Question 85, identify the following sequences as linear, exponential, or other. For the linear and exponential sequences, identify the rate of change and whether it is a constant that is added or multiplied. So on part A, we have 12, 144, and 1028. So you can see definitely that it's not going to be linear or arithmetic sequence because the adding is increasing by too much on each of these. If you multiply the 12 times 12, you get 144, and if you take 144 times 12, you get 1728. So this would be a geometric sequence, which represents an exponential. And then we also want to identify what the rate of change is and whether it is a constant that is being added or multiplied. So this is an exponential, and it is being multiplied by 12. And that's what we're supposed to do on each of these questions. So on B, we have 0, 5, 10, 15, 20, 25. So you can see pretty quickly that we're going to add 5 on each of these. So for that one, we're looking at linear, and we are going to be adding 5 each time. Question C, 0, 4, 16, 36, 64. So it looks like on this one, at first it might look like it's supposed to be multiplied, except if you notice, 0 times 4 is not 4 anyway, so let's go back here. We could add 4, but then we're going to be adding 12, so definitely not working out here on this one. So this is going to be other. And since it's not linear or exponential, we don't answer the question of the rate of change. And then D, 1.5, 2.25, 3.375, 5.0625. Once again, we might start by looking at linear, but you will see once again pretty quickly that when you go to add, it's not constant. So the next question is there something that would be multiplied by 1.5 to get 2.25 and 2.25 to get 3.375? That's hard to look at because it's not as easy as A, where it's a nice number of 12. So what we can do to check this is we can work backwards. So if we're asking ourselves, 1.5 times what is equal to 2.25? So if we divide by 1.5, we get a value of 1.5. Okay, so same thing on the next one. If we take 2.25 times what is equal to 3.375, and we divide that by 2.25, we get x equals 1.5 again. So it looks like the multiplier is 1.5, and you can double check by multiplying each term by 1.5. And if you multiply this by 1.5, you get 2.25. And if you multiply this by 1.5, you get 3.375. And so on here. So it is true that it is exponential. And it gets multiplied by 1.5. Question 86. Solve the system of equations below. So it looks like it is set up for substitution, so we will use substitution. You can use any method you want, but it's set up for substitution, so that's what I'm going to use. I'm going to substitute negative x minus 2n for y into the other equation. Then I have to distribute negative 3x, so I'm distributing negative 3 to negative x. Negative 3 times negative x is positive 3x, and then negative 3 times negative 2 is a positive 6. Combine the like terms, subtract 6 from both sides, divide by 8, and we get x equals 2. And then now we can plug that back in. This is the opposite of x, minus 2. So negative 2 minus 2 is equal to negative 4. So 2 comma negative 4 is our solution. If we want to check, we could plug that back in to both equations to make sure it works. Question 87, write the first 5 terms of each sequence. So on part A, you can see that this is what we call the next term. That's the term we're trying to find. This is the now term, or the term that we know, and then times by -2. So it's -2 times the term that we know. So we know the first number in the sequence is -3 because it tells us when the term 1 is equal to -3. So then we're going to take each of these terms and multiply by -2. So that would be +6, -12, multiplied by -2 again, and then one more time to get -48. So those are the first 5 terms of the sequence. On B, once again, this is next. It's equal to the now term, what term we currently have, -5. And so the first term is 8. Once again, that's given to us right here. And then we just keep subtracting 5. So if we subtract 5 once, we get 3. Subtract 5 again, -2, -7, -12. And those are the first 5 terms on that one. And then on part C, so we'll do it again. This is the next, and this is the now term raised to -1, which, remember, something raised to the -1 is equal to the reciprocal of that. So this would really be the same thing as 1 over whatever that current now term is. So the first term, once again, is given, which is 2. And so therefore, if we take the reciprocal of that, that would be 1/2. And then you take the reciprocal of that, which would be 2. And so it just keeps going back and forth between these two numbers because you're just doing the reciprocal back and forth. And there are the first 5 terms of each of the 3 sequences that are written in recursive form. 88. The graph below compares the gas mileage to the weight of numerous vehicles. Describe the association between these two quantities. So we have on the x-axis the weight in tons of the vehicles, and then on the y-axis we have the miles per gallon. So we are looking to describe the association between the two quantities. So you can see that kind of have 2 different groups here, but it looks like either way the data is decreasing as x increases. So as the weight in tons increases, the miles per gallon does decrease. It would look like definitely a negative linear association. Since the points aren't real close together, maybe on the line, we could call it a moderate negative linear association. Doesn't really look like there's any outliers on this as well. And so we can write that out as a moderate negative linear association with no outliers. Question 89, find the missing areas and dimensions of each generic rectangle below, then write each area as a sum and as a product. So we're going to write it as a sum and as a product. Okay. So let's take a look at A. We have 16x squared as the area given a length of 4x. So what times 4x gives you 16x squared, and that would be 4x. So 4x times 4x is 16x squared. Alright. Then we know that this is a 1. So the only way we can multiply and get 1 is if each of these were 1s. So these are positive 1s. And then now we know these boxes, 4x times 1 is 4x, and then 4x times 1 on that side is 4x. So if we're going to write this as a sum and a product, find the missing areas and dimensions. So we do have the length would be equal to 4x plus 1, and then the width is equal to 4x plus 1. Those are your dimensions. And then we're going to write it as the area as a sum and product. So we'll do the product first, which is the length times the width. And this would actually be a square as well. Same length and width, and that's equal to 16x squared. We can add the 4x's to get 8x plus 1. And so that would be all the information we're looking for. As I kind of look back at something here, I realized that to get a 1 here, I made the assumption that it would be positive, plus 1 and plus 1. But we also, technically, if we're going to get a 1 down here, we could have done a negative 1 and a negative 1. And that would have worked as well. What that would have changed is this would have been a negative 4x and a negative 4x. So our area would have been 16x squared minus 8x plus 1. So if we did do this one, just to make sure we're clear, because this would have worked as well. This would have been 16x squared minus 8x, but still a positive 1 there, and it would have been 4x minus 4x minus 1 times 4x minus 1. So that is another possibility on that one. On part B, we have another generic rectangle here, and this area is given as negative 12x, and we know this length is negative 3. So what times negative 3 gives you a negative 12x, or you could just divide, and that would be 4x. So we know that length is 4x. If this is 4x, then we can get this one right here by taking 2y times 4x, and that would be 8xy. And let's see, we have 10y here, knowing that this length right here is 2y, so this length would be 5, and I can move that to that side as well. So 5 times 2y would be 10y, and therefore 5 times negative 3 is negative 15. So the length on this one of them would be 2y minus 3, and the other side length would be 4x plus 5. And written as a product and sum, 2y minus 3 times 4x plus 5 is equal to, it doesn't look like we have any common terms here, any like terms, so we'll just write everything down. We'll go with the 12x first, plus 8xy plus 10y minus 15. And I wouldn't necessarily care which order you had those numbers, those terms in for that one. So that is rewriting using generic rectangles as a sum and as a product. Question 90. This problem is a checkpoint for writing the equation of a line. It will be referred to as checkpoint 5b. Use the given information to write an equation of the line. Slope 2 and passes through 10, 17. So if we have the slope and we have an ordered pair that the line goes through, we have m, x, and y. So we can rewrite this into slope-intercept form. 17 is equal to 2 times 10 plus b. So 17b equal to 20 plus b. Subtract 20, and b would be equal to negative 3. So the equation of this line would be y equals 2x minus 3. On part B, you're given 2 points, so the first thing you need to find is the slope. So the slope is the change of y over change of x, so negative 4 minus 5, and 1 minus negative 2. You could always rewrite it the other way. I got negative 9 over 3, where if you do it the other way, you'll get positive 9 over negative 3, but the slope would still be negative 3. And then we'll use one of these points for x and y and do the same thing that we did above. Y is equal to mx plus b. Y would be 5 is equal to negative 3 times negative 2 plus b. 5 is equal to 6 plus b, so b would be equal to negative 1. Y equals negative 3x minus 1. So that's if you're given 2 points, you got to find the slope first. On part C, you're given a lot of information here, 5 different points. We need to find the slope as well, so we can use any 2 points that we want. I'll choose the last 2 points. And so remember, these ordered pairs, one of them would be 3, 0, and the other one is 6, 2. 6, 2. So let's see, to find the slope, we would do 2 minus 0 for the change of y, 6 minus 3 for the change of x, and then 2/3 would be the slope. Now this point right here you might recognize as the y-intercept. So we actually already have the y-intercept in the table, so therefore we can go ahead and just write the equation of the line now that we have the slope. Y is equal to 2/3 x minus 2. So that's how you write the equation of a line given a table. And then the fourth way here, we have a graph, and we want to find either a couple points on here that are nice, or we can use the slope triangles and the y-intercept to write the equation. So it looks like the graph crosses right there on the y-axis. It looks like each of these represent 1 unit, so that would be at 0, 9. And then we have to see if we can find out where it intersects nicely. It looks like maybe right here, and maybe, let's see, and then maybe right here as well. So the y-axis goes up by 1s. So it looks like here's our triangle, 1, 2, 3, 4, 5. It's a positive 5. And then be careful because the x-axis, each, the way it's labeled goes up by 1, but each one of these represents a half a unit. So this would be a half, 1, 1.5, 2. So this actually represents 2. And so therefore, and this was supposed to be a plus 5 on this side. Try to fix that there, but this is a positive 5 and a positive 2. So the slope, change of y over change of x, the y-intercept appears to be at 0, 9. So the equation is y equals 5/2 x plus 9. And so that is the checkpoint for writing linear equations, equations of lines in all sorts of different forms and different information given. At this point, we should be pretty close to have mastered this skill.